Hello everyone. This video about the deriving of some trigonometric function like tan x, secant x, and cosecant x. For each one to prove or to find the derivative, I'll use quotient rule. The quotient rule that has a function u and a function v is form like u over v. You want to derive this division of these two functions. The value is v squared in denominator, u prime v minus prime u. By applying this rule, if you want to derive tan x, for example, tan x is simply sine x over cosine x. So I want to derive sine x over cosine x. Now I have a quotient function. Apply this rule now. By squaring denominator, I have sine squared x. Derivative of sine is cosine x, dot the other one cosine x, minus derivative of cosine negative sine x into the numerator sine x. By simplifying this, I have now cosine times cosine is cosine squared x, minus negative is plus, sine times sine is sine squared, x over cosine squared. And sine squared plus cosine squared for any angle is 1. So 1 over cosine squared x is simply secant square x. So the derivative of tan x d by dx for tangent of the angle x is simply secant square x. If you continue by the same way to derive tan x simply cosine over sine. So I have cosine x sine x. I want to derive this function by applying quotient rule, just square denominator, and derive sine negative sine x and denominator sine x minus derivative of denominator, which is cosine x, derivative of sine is cosine, times the numerator cosine x. Simply, I have now negative sine squared x minus sine squared x over sine squared x. This denominator is simply negative 1. Because sine squared plus cosine squared is 1, and I have a negative in both terms, so it's negative 1 over sine squared x. Simply, it's a negative 1 over sine is cosecant, 1 over sine squared is cosecant square x. So the derivative of tan x is simply negative cosecant square x. Okay, now let's show you how can you find the derivative of secant x. Secant is the reciprocal of cosine. So the secant x simply can be written as 1 over cosine x, and 1 over cosine x by applying quotient rule. They did now, it's a cosine squared x, derivative of 1 is 0, dot denominator cosine x, minus derivative of cosine x, negative sine x, times the numerator 1. So negative and negative is positive. So I have sine x over cosine squared x. I can split now this function as 1 over cosine x dot sine x over cosine x. Simply 1 over cosine x is secant x, and sine of cosine is tan x. So the derivative of sec x is sec tan. Derivative of secant x, sec x tan x. Finally, by the same way, I can find the derivative of cosecant x. The cosecant is the reciprocal of sine x. So the derivative d by dx of 1 over sine by applying quotient rule, that's right, sine squared x, derivative of 1 is 0, times sine x minus derivative of sine x times the numerator 1. So I have now negative cosine x over sine squared x, which can be written as negative 1 over sine x times sine x over sine x. The sine squared x in denominator can be split into sine times sine. It's negative 1 over sine is cosecant x and the cosine over sine is cosine x. So the derivative of cosecant x is negative cosecant cosine x. So in general now, this is a derivative of some important function of x. It's a derivative, the prime of x, the sine x, it's a derivative of cosine, sine x, derivative negative sine x, derivative of tan x, secant squared x, derivative of tan x, negative cosecant square x, the derivative of cosecant x, negative negative cosecant x tan x, and finally derivative of sec x tan x, secant x tan. This is the derivative of sine x and x and x and their reciprocals. Thank you so much. You will see that each function starts with c, its derivative is negative. Look, sine, cotan, and cosecant, all derivative negative. Yes. Thank you so much. See you next time. Goodbye.